Hello everybody, in this video I'm going to be teaching you how to integrate using U-Substitution. I'm going to provide a quick big idea of U-Substitution and then I'm going to go into the example, so if you don't want an explanation as to what this is, feel free to skip ahead. Okay, so I want you to think of U-Substitution as the reverse of the chain rule from derivatives. When we were taking derivatives, we used the chain rule to deal with composite functions. Now that we're integrating, we need a way to undo that. That's where U-Substitution comes in. We're going to make the inside of a function into something far simpler by letting the inside of something equal u. And that way, we're able to integrate far more easily, I guess. Yeah, words. English is hard, guys. Okay, so step 1, identify an inner function. Okay, what's inside of something? X squared. Therefore, that's going to be our u. Okay, boom, we already did step 2 as well. We did step 1 and step 2. Let u equal that inner function. We just did. Now we have to differentiate and solve for dx. So what the heck does that even mean? It means we need to find the derivative. So du dx. So what's the derivative of x squared? I hope you freaking remember it's 2x. Right? Okay. Then it's saying we have to solve for dx. Why are we solving for dx? Well, because when we solve for dx, we get to plug it into, where dx was. And then we get to cancel out some stuff and it looks pretty, but let's... one thing at a time. Okay, so let's solve for it. In order to solve for it, what do we have to do here? I'm going to do it in a different color. Let's do it in pink. We need to solve for dx. So let's do this. Now we have du equals 2x dx. And again, we're solving for dx. So that means we're going to divide that 2x. Now we get dx equals du over 2x. Okay, now we have completed this portion. Step 3 is complete. Differentiate and solve for dx. We have solved for that. Now, substitute. Okay, now our integral is going to be written as the following. 2x cosine of u, right? Because we said that u equals x squared. And our dx is now this guy, right? So we have du over 2x. Okay, now the beauty in this is all over 1, right? Okay, so that means 2x is in the numerator, and we have a 2x in the denominator. So what does that mean? It means we could cancel it out, yeah. Okay, now that we have canceled that out, we have simplified it and made our integral so much simpler. So easy. Okay, now we can integrate as usual. Okay, so the integral of cosine. I like to think of it as what derivative would give me cosine. And the derivative that would give me cosine is sine. So our answer is going to be sine u plus c. Okay. So we have substituted, we have now integrated, now we have to substitute again. What are we substituting? Well, what we put as u. So our final answer is sine of x squared plus c. Okay? It's honestly kind of gross, but it gets easy. It gets easy. It's fine. All right, let's move on to another one. Okay, I'm not gonna go into some big explanation this time. I'm just gonna jump right into it, and I hope you are seeing what's happening here. I'm gonna do this. I don't know. I'm feeling pink. I'm feeling pink today. Okay, so let's jump into this. Again, our u is gonna be something inside. So immediately I see something inside, so that's gonna be her. Also, don't be afraid to try it out. Midway through, you'll see if things are canceling out or not. If things are canceling out, okay, then you chose the right thing for you. If not, then you didn't, and you have to pick something else. So, yeah. Okay, du dx is 2x. Again, the derivative of a constant is 0, so nothing there. We need to solve for dx. I guess I'll show all the steps. I mean, this is kind of tedious to do over and over again. But whatever, I'll do it for you. Now we need to get dx alone. So we get dx equals du over 2x. Again, we must rewrite our integral. Okay. Excuse me. Just a girl. Okay, sorry. Okay, so we have 2x times u to the 4th power, and then du 2x, right? Because this guy right here. Beautiful. Now we can, again, right, this is all over 1. That means that this guy's in the numerator and this guy's in the denominator, and they're being technically multiplied to each other, right? So these guys cancel out. We get the integral of u to the 4th du. Now we can integrate. We get u to the 4th power plus 1 over 4 plus 1 plus c. Never forget that dang c. We get u to the 5th power over 5 plus c. And now we have to do our last step, which is substitute once more. We let u equal x squared plus 3. So what are we going to put in here? X squared plus 3 to the 5th power over 5 plus c. That'll be our final answer for this one. Okay, feel free to pause the video and try this one out. She's kind of scary, but it's not that bad. It really isn't. Again, it's going to be inside of something, right? Bam. That's you. I kind of want you to, like, every time I'm about to start it, I kind of want you to pause the video and guess what u is going to equal, because that's, like, honestly probably, like, the hardest part about this whole thing. Okay, now let's keep going. Du dx. Just 2x again. Okay. All right. Again, I'm not going to show the part where I solve for the, like, I'm not going to show, like, all the tediousness of that. I feel like it's pretty obvious what I'm doing. I'm going to do it for, like, the harder ones. But not this one. I feel like it's very visible as to what I'm doing. Let's rewrite our integral. X times square root of u. And then dx is what? Du 2x. Again, this is over 1. It's in the numerator, so these x's can cancel out. We get the integral of the square root of u du over 2. Now, 2 is actually a constant. Well, actually, it's in the denominator, so it's 1 over 2, right? So 1 over 2 is a constant, which means we can pull her out. So I'm going to pull her out. And then we have to rewrite this guy because it's not in proper form for integration. So we have to write it as u to the 1/2 power. And then du, because again, we pulled out the 1/2. And now she's pretty and perfect, and we can integrate like usual. So 1/2 times u 1/2 plus 1 over 1/2 plus 1 plus c, right? I'm kind of running out of room. I'm going to start writing over here. My arrows are so ugly. Okay. 1/2 times u to the 3 over 2. Okay. Then again, 3 over 2 plus c. Now, I remember when I watched this for the first time, I was like, what the hell am I? Okay, what the hell, Burton? Okay, I'm so sorry. Okay, so we had to do the reciprocal to get rid of that, because that's like a no-no. It's like illegal. So this cancels out, and we get 1/2 times 2 over 3 u to the 3 over 2 plus c. 2's are going to cancel out. Like if I were to, let me just distribute it. I don't want you guys to get confused. 2 times 1 is 2. 2 times 3 is 6. What does that simplify to? It's going to simplify to 1/3, which is what you get when you literally just cross out those 2's immediately. So we get 1/3 times u to the 3/2 plus c. And then our final step would be to replace what we had u equal to. So when we replace u, we get our answer is 1 over 3 x squared plus 1 to the 3/2. Well, not 3. Yeah, exactly 3/2. Yeah. 3 over 2 plus c. That's our answer. Okay, that was a little rough. Okay, now this guy. Let's do this. Again, u is always going to be something inside of something, right? And then also a good indicator too sometimes is like, let's say we do this, right? We let u equal 1 minus x to the 3rd power. And we find the derivative, right? The derivative of this is 3x squared. If you can find this like base part anywhere in your integral, that's a good indicator that you're doing the right thing. Okay? Let's keep going. I'm not going to show every little freaking step for this. I'm sorry. I'm just not. I can't do it. It's just going to take too much work to like do all that. we get dx equals du negative 3x squared. Okay, so we write this integral. We let 1 minus x3 equal u. And then dx is getting replaced with du over negative x squared. Well, negative 3x squared. Hello. And now these guys cancel out perfectly. So let's rewrite our integral. We have 1 over square root of u du over negative 3. Again, she's a constant. We have a negative 1/3 there, right? That's a constant, which means she can get pulled out to the front of the integral. So I'm going to do that. And then we also need to rewrite this u, because it's not in the proper form for us to take the integral of whatever antiderivative words, okay? So we have to rewrite it once more, okay, as u to the 1/2, but then we have to bring it from the denominator to the numerator. So it's actually going to be u to the negative 1/2 du. Now we can find, well, we can integrate. Now we can finally integrate. Okay, when we integrate, we get negative 1 over 3 times u to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c. Hope I startled you with that one. I'm gonna change the color. I don't know. I'm not feeling this pink anymore. I'm gonna go back to orange. Get negative 1 over 3 times u to the 1/2 over 1/2 plus c. And then we have to get rid of this fraction in the denominator because it's a no-no, illegal, frowned upon. So we have to do the reciprocal for that guy. We get negative 1/3 times 2 times u to the 1/2 plus c. That's just negative 2 over 3 u 1/2 plus c. And then we have to replace what we let u equal. So our final answer is going to be negative 2/3 times 1 minus x to the 3rd power to the 1/2 plus c. So that's our final answer for that guy. Okay, fun, so much fun. Okay, actually not that much fun, kind of annoying and aggravating, but whatever, it's gonna be okay. To find the integral of tangent and cotangent, surprise, 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 you need to use substitution, yeah. Okay, so how does that even work? Well, tangent is equal to sine over cosine, right? And just like that, now we can use U-substitution. U-substitution lets something inside of something equals 0, right? So which one do you think is going to be, sine or cosine? The first time I did this, I guessed it wrong. So if you guessed it wrong, it's going to be fine. But it's going to be cosine. Because, like, remember, when you solve for, like, du dx, typically you get du, dx ends up equaling du over something, right? And when you have that, you're going to end up canceling out the bottom and the top. So that's like also kind of a good way to think about it. I feel like you start thinking like 10 steps ahead, like once you start doing this over and over again. Okay, but whatever. Sorry to go on a tangent. Okay, I'm so sorry. Okay, du dx equals what? Sine. Wait, no. Stop. Negative sign. Such a silly girl. How dare I? Okay. Now we're going to solve for dx, right? We get du equals negative sine of x. Dx equals du over negative sine of x. And would you look at that? What I just said was going to happen just happened. We get sine of x over u. And then we have du over negative sine of x. Okay, so that is going to cancel out. We're going to be left with 1 over u du over negative 1. Or you could do negative du. I think it does not matter, okay? Either way, this is a constant that needs to get pulled out. So let's pull her out. Now we have negative 1 times the integral of 1 over u du. And remember, 1 over u is natural log. Okay, so this is where it gets even more annoying. We get -1 times ln absolute value of u plus c. Okay, now we've integrated. All right, now I'm gonna switch it up. Okay, we have negative ln absolute value bars. Okay, what was u? We let u equal cosine of x. Okay. Now, it's done. No, it's not. It's not, because we have log properties. There's a log property that I honestly completely forgot about, but it states negative ln of a equals ln of 1 over a. So, therefore, this guy can be rewritten, and it can be written as ln of the absolute value of 1 over cosine x plus c. Okay? And what is 1 over cosine x? Well, that's if you're using trig identities, right? Okay. That's equal to secant of x. So our final answer is ln absolute value of secant x plus c. Now, how aggravating was that? I don't know if your professor would hate you for this, but like I kind of just like try to memorize these two so that I know when I see tan of x that it's going to be that, but I also don't know if your professor would want to kill you for that, so you know, at your own risk. Okay, let's do cotangent. Please pause the video and try it. It's like less bad than the last one. This one doesn't require a log property. Okay, so you can definitely do it. So pause the video, try it out. Why not? Get the practice in. You're here. You might as well. Okay? So let's do it. Integral of cosine x over sine of x dx. U is going to be sine. Du dx equals, the derivative of sine is cosine. And then we must solve. When we solve, we're just going to get du over cosine of x. Now let's rewrite our integral. We have cosine of x over u. And then du cosine of x. These cancel out. We get 1 over u du. Beautiful. All right, now let's integrate. We get ln we get ln absolute value of u plus c. Okay. Now we must substitute what we let u equal, which is sine of x. So our answer is ln absolute value of sine of x plus c. That was way better. Way better than tan, right? Okay. Okay, this one's not that bad. I promise it's going to be okay. I'm going to hold your hand, Pookie. It's going to be fine. We're going to let u equal 7x plus 2. The derivative of that is what? 7. 6, 7. Okay, let me stop. All right. God. Okay. All right, when we solve for dx, we're going to get du over 7. Okay. And then we're going to rewrite this. Beautiful. Oh, wait. Not beautiful, idiots. Du over 7. Now it's beautiful. Okay. Now we notice we have a constant. That's a 1 over 7, which means she is getting pulled out immediately. Okay, beautiful. And now we can just integrate. I mean, there's really nothing to do, right? So we get 1 over 7 times what derivative is going to give you cosine? That's going to be sine plus c. All right. I get 1 over 7 sine. We're going to substitute what we let u equal to, 7x plus 2 plus c. Okay, I'm sorry. I'm going to stop being so annoying. So that's our final answer. That one's really easy. Nothing too crazy. Nothing too silly. Let's move on. Ooh, okay, less fun. All right. So again, something inside of something. Okay? In this case, it's going to be that, right? U equals what? Square root of x. we need to take the derivative of that. But in order to take the derivative of that, we actually have to put it in its proper form. So it's not square root of x, it's going to be x to the 1/2, right? The derivative of that is 1/2 x to the negative 1/2. She is going to be super annoying to deal with already. For this one, I'm going to have to show every single step because I don't want anybody to get lost. Okay, so we're going to solve for dx, right? We need to do the reciprocal. Okay, we get du equals 1/2. And for the sake of not getting lost, I'm going to throw this guy in the denominator. So now it's going to be written as 1/2 square root of x. Okay, this is just so we don't get confused. Dx over 1 is being multiplied to this guy, right? So dx can go right there. Or it could go up here. It's up to you, but I'm going to write it on the side. Okay, we need to still solve. We need to solve. So we need to solve for dx. To solve for dx, boom, reciprocal once more. Okay, now we get what? Dx equals, I never know to put it in the front or in the back. Do whatever you want. I'm going to do this. If it's illegal, I'm sorry. Okay, now we get this. Dx equals 2 times square root of x du. And it's looking good. It's looking good. No complaints. Let's rewrite our integral. I'm going to do it in blue. So we have cosine of u over the square root of x. And then dx is now 2 times square root of x du. Again, now this is a little different because usually we have like du over some number, right? But this time it's different because we actually have the number right next to du. So this is all over 1. So now when we cross this out, we get that. We get, let me write this, integral of cosine u 2 du. So when we pull out our constant 2, it's not 1/2, right? It's 2. So let's pull her out. We get this. Now we can integrate. All right, what derivative is going to give you cosine? That's going to be sine, right? So we have 2 sine of u du. We must replace u with what we let it equal to. And then we get our final answer, 2 sine square root of x plus c. Oh my god, plus c. I cannot believe I just did that. And that's our answer. Not that bad. Not that bad. Not that bad. We have so much. We have so many problems left. Oh my gosh. Okay. Let me try to do this a little faster. U is going to be something inside. So in this case, it's going to be this horrendous freaking mess. And then, of course, we need to rewrite it so that we can actually integrate. I mean, differentiate. Oh! Okay, du dx equals what? Well, we have 3 times negative 2x to the negative 3. Okay, so basically that's just negative 6x to the negative 3rd power. Okay, she's going to be so annoying too. I just know she's going to be annoying. Okay, I'm going to show all the steps for this, right? Du equals negative 6x to the negative 3rd dx. Again, I'm going to bring that guy to the bottom so we have no confusion. Now we need to do the reciprocal. We get what? Oh my gosh. We get x to the 3rd over negative 6 du equals dx. Okay, let's take a look. Already it's looking good. You see this? That's perfect. Beautiful. Beautiful, beautiful indicator that we're doing the correct thing. Okay, so let's rewrite it. We have 1 over x to the 3rd sine of u. And then dx is now x to the 3rd over negative 6 du. Okay, let's cancel some stuff out. We could cancel this. Now we're left with sine of u. And again, 1 over negative 6 du. This is a constant. She's getting pulled out to the front. Okay, now we can integrate. Okay, so be careful here, right? So the derivative of what's going to give you sine? Okay, well, that's going to be a negative cosine, right? Negative cosine. So we get negative 1 over 6 times negative cosine of u plus c. Okay, so now this is positive 1 over 6 cosine of u plus c, 1 over 6 cosine. And then we're going to plug in what we let u equal plus c, and that is our answer. Not so bad. Not so bad. This one's also not bad. Okay, if you're like, oh, what is it going to be? I don't see anything instead of anything. Actually, yes, there is. See that 4? That can also be written as sine of x over cosine of x to the 4th power. So if you didn't see what u was before, I pray you see it now, because if not, that's still good. No bueno. Okay, let's keep going. U equals cosine of x. Du dx is what? The derivative of cosine is negative sine, right? Now we're going to solve for dx. I'm not going to show the steps for this one. Beautiful. Let's rewrite this. U to the 4th power, then du over negative sine x. Okay, Siri, calm down. These cancel out. We're left with 1 over u to the 4th power, and negative du. Again, that's a constant. Negative 1 is a constant. She's going to get pulled out to the front. Negative 1. Okay, beautiful. Now we can integrate. Wow, this is... There we go. Now, now we can't even integrate because the u to the 4th power needs to be in the numerator. So let's fix that. Now we can integrate. So let's integrate. Negative 1 times u to the negative 4th plus 1 over negative 4 plus 1 plus c. Negative 1 times u to the negative 3rd power over negative 3 plus c. Okay, let's bring this guy to the denominator. So we get negative 1 times negative 1 over 3. It's going to be what? Positive 1 over 3. Except we're bringing the u to the negative 3 to the denominator. So it's actually going to be 1 over 3 to the u. 3 times u to the 3rd power plus c. We must replace u for what we let it equal to, which is cosine of x. So our final answer is going to be 1 over 3 cosine 3x plus c. So that is our final answer for this problem. Not bad. Well, kind of bad. Okay. This one, really simple, okay? I kind of gave you, I probably shouldn't have even included this, but like the more practice, the better, right? Do this one on your own. Please do this one on your own. You can do it. I believe in you. U is going to equal sine of x. Okay, the derivative of sine is cosine. Okay, dx is going to give us du dx. Oh my god, no. Du cosine of x. There we go. Let's rewrite our integral. We get cosine of x u to the 8th power, and then du over cosine of x. Beautiful. These are canceling out. Again, this is over 1. Those cancel out. And we're left with u to the 8th power du. Beautiful. And we can integrate almost immediately, right? U to the 8th power plus 1, 8 plus 1, plus c, u to the 9th power over 9 plus c. Then we must, plug in for u. So we get sine 9th power over 9 plus c. And that is our final answer. That was actually not bad at all. This guy. Oh, okay. Okay, so usually in this case, like usually in the past, on all these problems, we would take the denominator for the most part because it would cancel out. But in this case, it wouldn't cancel out because think about it. The derivative of x is what? It's 1. And 1 is not going to help cancel out jack crap, right? So we need to actually let the numerator equal to u. Okay, and the derivative of ln of x, I hope you remember, is 1 over x. Now I'm going to show the steps for this one so that we don't butcher this. Okay, dx over 1, dx over 1, we get du equals what? 1 over x dx. Okay, we're solving for dx, right? So we need to do the reciprocal of 1 over x, which is x over 1. And we get that dx is equal to x du. Now we can rewrite our integral, u over x, and then bam. Again, this is over 1, right? So these guys cancel out. We're left with u du. Beautiful. Let's integrate u to the 1 power plus 1, 1 plus 1 plus c. We get u to the 2nd power over 2 plus c. Let's replace our u, and we get ln of x squared over 2 plus c as our final answer for this one. Not bad. Not bad at all. Okay, this one. Okay. Less fun, but it's going to be okay. Guess what we're going to do for u? It's going to be ln of x. Okay. Du dx, same thing as before, 1 over x. I'm not going to show the steps for this one because we literally just did it. So that's pretty obvious, right? Okay. Now let's integrate, or rewrite our integral, rather. We get x times u to the 2nd power. And then dx is equal to x du. Again, this is over 1, so this is going to cancel out. We're going to rewrite our integral. We get 1 over u to the 2nd power du. Okay, now we still can't integrate because we got to bring this guy to the top. So let's rewrite it. We get u to the negative 2nd power du, right? Now let's integrate u to the negative 2 plus 1 over negative 2 plus 1 plus c. What is that going to be? U to the negative 1 over negative 1 plus c. We got to bring this guy back down to where he belongs. So we get negative 1 over u to the 1 power, right? And then replace u. So our answer is going to be 1 over ln of x plus c as our final answer. This guy, not bad. Really not bad. Really not that bad. I think it's pretty obvious what you have to do. So, kind of repetitive at this point. After a lot of practice, it really does become repetitive. Right? We just did that like twice already. Okay, let's rewrite our integral. Sine of x. Oop, girl, what did you just do? Okay. X du, again, this is over 1, so these cancel out. We're going to rewrite our integral. Okay, there's nothing left to do. Now we can integrate. What derivative is going to give you sine? It's going to be negative cosine of u plus c. Now we must replace what we let u equal to. So our final answer is going to be negative cosine of ln of x plus c. Nice and easy. Not bad at all. This guy is going to be pretty interesting, I feel. I threw this in here because I feel like you'd see this. So let's do this. Again, inside of something, pick anything. You're always going to figure it out halfway through. If something doesn't cross out, you messed up. U is going to be x squared plus 4x. The derivative of that is 2x plus 4. And already, this is a pretty good indicator that this is all going to cross out. Okay. Oh, I forgot dx. Rude. Okay, let's solve. Again, this is all one thing now. So du equals 2x plus 4 dx. dx is going to equal du over 2x plus 4. Let's rewrite our integral. We get 2x plus 4 over u, and our du over 2x plus 4. This completely cancels out. We must rewrite our integral as 1 over u du. And 1 over u is, drumroll please, it's ln, absolute value of u plus c. We're going to replace u with x squared plus 4x. And that is our answer. Okay, this guy. Again, I feel like it always looks so much worse than it actually is. Off the bat, you can just pull out that 12, right? So we can actually write this immediately. We have e to the x times cosine of e to the x, ironically. Okay. Again, u has to be something inside of something else. So u is going to actually be e to the x for this one. And it's kind of funny. But the derivative of e to the x is e to the x. And then we have du equals e to the x dx. And then when we do this, we get dx equals du over e to the x. Okay? Let's rewrite this. Cosine of u du over e to the x. Again, this is over 1. This cancels out beautifully. We get 12. And then cosine of u du. All right. The derivative of what gives you cosine? That's going to be sine. So our answer is going to be 12 times sine of u plus c. We must replace u with what we let it equal to, which is e to the x. And that is our final answer. Really not that bad. This one, a little tedious, but still not that bad. Really not that bad. Okay, which one do you think it's going to be? This one's going to be the denominator. So e to the x plus x. Du dx. Okay, well, the derivative of e to the x is e to the x. The derivative of x is 1. So, would you look at that? Pretty good. Pretty good. Now, let's solve for dx. We're going to get dx equals du over to e to the x plus 1. Now we get to rewrite this integral. We have e to the x plus 1 over u. And then du over e to the x plus 1. These completely cancel out. We're left with 1 over u du. And then the integral of 1 over u is ln, absolute value of u plus c. So our final answer is going to be ln, absolute value of e to the x plus c. Okay. Now this guy, I mean, you could take a gander, take a little guess, see what's going to happen. Try it out. We're going to get e to the x, right? dx is going to be du over ex. We can rewrite this easily. I feel like after like the first few problems, these just become like, I don't know, like second nature almost. These cancel out. We're left with 1 over u du. I mean, these really aren't bad. Or maybe it's just that. Okay, we get ln, absolute value of u plus c. So our final answer is going to be that guy. Beautiful. All right, please tell me. That's it. We're still not done. Okay, we're still not done. It's going to be fine. We're going to let u equal square root of x. Can you guess which one it's going to be? Yeah, it's going to be that guy. All right, let's rewrite it. Oh, no, not rewrite it. Let's find the derivative. Excuse you. Okay, again, we have to rewrite it as that so we could pull the derivative. Now let's differentiate. And then for the sake of not getting lost, I like to put this guy in the denominator after we already found the derivative so that we don't get confused. Okay, now we need to find dx, so we have to use the reciprocal to get rid of this guy. We get dx equals 2 times the square root of x du. Let's rewrite our integral, e to the u over the square root of x, and then 2 times square root of x du. Again, this is over 1, so this is going to cancel out. We're left with the integral of e to the u 2 du, and we can pull out that 2, so we get 2 integral of e to the u du. Now we can integrate. 2 times the integral of e to the u is just e to the u plus c. Right, let's keep going. So 2 times e, and what was u? We let u equal the square root of x. So that is our final answer for that guy. Now this one, kind of similar, a little similar. Try it out. Should be nice and easy. All right, again, this is a beautiful indicator already. We're going to get dx equals du over 3x squared. The integral of e to the u, x squared. And then we have du over 3x squared. Again, this is over 1. So this cancels out. We're going to rewrite it, e to the u, du over 3. We can pull out this constant. This is a 1 over 3. That's going to get pulled out to the front, 1 over 3. And then the integral of e to the u, du. Integral of e to u is e to u, plus c. Now we have our final answer. 1 over 3 times e to the, what? X to the 3rd power plus c as our final answer. Beautiful. Last one. Yay. Okay, this one. Ooh, this one is like, ooh, just gives you a little bit of agita. All right, let's jump right into it. For this one, always inside of something, right? It's gonna be this guy. It's gonna be that whole thing. Okay, so let's see what we got here. We have du dx of that. All right, so we kind of have to think a little bit back to derivatives, right? So the derivative of cosine is negative sine, right? But then you have to multiply this times the derivative of 4x. So we have du dx equals negative sine of 4x times 4, right? I hope derivatives didn't like completely leave your brain, okay? And then this can also be rewritten as du dx equals negative 4 sine of 4x. All right, now we can solve for dx. We get du equals, I'm not going to do all that. I'm not going to show you it. I feel like it's pretty obvious at this point, right? Du over negative 4 sine 4x. Okay, now we can rewrite our integral. So we have the integral of e to the u times sine of 4x. And then dx is now du over negative 4 sine of 4x. Beautiful. Again, this is all over 1. So this completely cancels. We can rewrite our integral, e to the u. Then we have du over negative 4. So our constant here is negative 1 over 4. That can be pulled out to the very front. We get e to the u and then du, which is beautiful. And now we can integrate. Get negative 1 over 4. And then the integral of e to the u is just e to the u plus c. Then we must replace it with u. And we said u equals cosine of 4 of x. So our final answer is negative 1 over 4 e to the cosine 4x plus c. And that is our final answer. That is all for this video. In the next video, I'm going to go over U substitution, but special cases where you kind of have to mess with like what U is equaling to, because it doesn't like match up perfectly where we could cancel out. So those are like special cases, and I'm going to be covering that in the next video. And then after that video, we're going to go over definite integrals. So if that's something that interests you, please look out for those videos. And thank you so much for watching. Bye.